Okay, how much of me is in frame right now?
All of you.
Okay, cool. Good?
Yep.
Let's talk hang frames. We had two different sizes of hang frames for the 4K. One of them is the normal Schedule 40 1.5 inch pipe diameter that Jerry posted on Slack chat. I'll provide a link for that. And then one is the exact same design, but with thicker pipes. This one is 2-inch diameter pipes, and that makes the strength about 3 times stronger. And the reason we chose to do that was last year on the 3km Highline, when the wind picked up and it was an emergency situation, all of the force was on one of the legs and it did start to bow, so we wanted higher safety margins on this project. We used the 2-inch diameter pipe for the Highline, and then we used the normal 1.5 inch diameter for both the curtain rod and the sightline anchors. Since these are Jerry's design, I would recommend watching his video on how to set them up. He has good tips, but I will show you how we set them up for the 4km just so you can understand how we did it. So we've got our sling set up at the bottom so that the legs don't spread apart any further, and we've got a nice angle right here. You don't want it too narrow, otherwise it won't have much side-to-side support, but you don't want it too much wider than this, otherwise the force down and like bending these legs in will start to increase pretty rapidly. So this is a good angle right here, and now let's see how we attach our rings. So what we're using is a 5mm Dyneema eye-to-eye sling so that it's easier to loop it around, and it provides a lot of strength. We use 2 bomber rings so that it's redundant and strong enough. Aluminum rings will start to deform around 24 kilonewtons, and in an emergency scenario, it is possible that we could have gotten up to 24 kilonewtons. So we wanted to use something with much higher safety margins. And then to connect the eye-to-eye, we'll use a stainless steel quick link. To start off, we're going to loop this up over the top between the 2 legs over the hang point. Then we'll go down and through the 2 rings, and then through the legs, around one of the legs, back through the ring, around the other leg, and then we'll start going up and around the hang point. And this is, anytime you do a cross through, it's through the legs. And then we went around the hang point, back through the rings, and I'm going to take the other leg now and also go through the legs. In just a moment, I'll give a close-up so you can see how it all comes together. Oh, sorry. And now I'll connect the 2 eyes with my quick link. And you always want to tighten down those quick links with a wrench in real rigging scenarios. Great. So now you can see, once we've got our hang point, we have 1 strand going around each leg, and then we have 3 strands going up and over the top. Yeah. I'll just get a static shot. So here's our close-up of how we did our hang frame setup. You can see we've got the 3 strands going up over the hang point, 3 up, 3 down, and then we have 1 strand going around each of the legs. And if we look closely here, you can see that we have this strand's going from one leg straight through the bomber rings right here, and then around the other leg. That's different from Jerry's normal recommendation, but the reason we did that for this rig is because I find when you go straight through, that prevents friction from building up and makes it a little bit easier for the rings to slide side to side. So if wind were to pick up, then the direction of the Highline pole is going to change, and this way the rings can more easily adjust the direction that it's hanging at. All right, so now we have our anchor mostly set up. We don't have our master point yet for the webbing, but I'll talk you through how we stabilized our hang frame so that we made sure it didn't fall over. This is much different from the normal way to set it up. The GGBY standard, for example, which Balance Community recommends, is you have a bolt directly underneath the hang frame, and you pull your rigging points from each leg and your master point down to that bolt. We didn't use that because the sandstone in our location was so soft that we didn't think that a bolt would be strong enough to really give us the pull down forces that we needed. All right, so quick note when we're looking at these anchors, I'm just in my backyard in the dirt, so anytime I reference bolts, it's really our anchor stakes that are in the ground, and obviously, I hope it's obvious over the camera, these are not Highline rated anchors, so don't try to replicate this with just stakes. That being said, everything else is a very similar way that we set this up to the 4K. So we've got our 3-point BFK coming back from our bolts up to our master point, and since this is a BFK and it's not going to be a slide point, we have 2 soft shackles, and the reason I state that's okay is because it's not a rub point, you can use soft on soft. 2 soft shackles going from our master point or our BFK up to our 2 steel bomber rings. So this is our main connection that will be holding the force of the Highline from the rings down to our bolts. We've got a good angle in the downward direction from our hang frame down to the bolts. This provides a good downward force that helps stabilize our hang frame. Now, you'll notice that we have 4 whoopies in the system as well. We have a whoopie right here, from this leg back to the bolt, from this leg back to the bolt, and then 1 bolt out in front with 2 more whoopies. And the reason for that is we cannot kick the legs out of the hang frame in the backwards direction or in the forwards direction. So the reason we used whoopies is so that they're easily adjustable. As you add tension to the highline, especially in a world record scenario, when the tension ranged from pre-tension being around 1 kilonewton when we pull it across, all the way up to 10 kilonewtons or 11 kilonewtons when someone is on it, your anchor is going to stretch, and this master point position is going to want to move around. So you want to be able to move where your legs are as well to be able to account for where your master point is going to end up sitting. All right, this might be a little redundant, but I really want to drive home the key differences that we have here between what the normal GGBY or Balanced Community recommended setup is for a hang frame versus what we did. You can see that we have a bolt in front that is pulling the legs and maintaining forward direction pull, and they're not tight, but it won't allow the legs to shift. And then we also have whoopies in the back that are doing the same, so we can't move these legs forward and back. Normally you have a bolt right down in the center that then pulls each rigging point off of your legs downwards as well as your master point downwards. We didn't do that at the 4K because we didn't have good enough rock that we would have been able to trust the bolt to have that much direct pull in tension off of the bolt. One other way that this differs from the 4K setup is we actually had 9 bolts on our master anchor. Just because of the quality of the sandstone, that seems like pretty excessive, but we just really wanted to be sure that we would have good safety margins given how soft the sandstone was in that area. Now this anchor looks a little bit different than you might be used to for a normal highline anchor, and that's because we based it all around this releasable system that would be able to maintain safety ratios if someone was out on the line while we're releasing. We chose not to use a soft release because on the 3km Highline, the soft release binded up and it got stuck while we were trying to release, and it took us 15 minutes just to release a couple of meters of anchor into the system. There's a couple of key differences that I want to point out before we start, but then we'll dive into it. First, the webbing is different. We're using helium and green for this demonstration. We used Mark 5 on the main line and Axiom on the backup for the 4K. The pulleys here are not SMC pulleys. We chose SMC pulleys for the 4km Highline because of their strength rating. These pulleys here that are shown are neither double on the bottom ones, these ones are double, nor are they strong enough. And then the other key difference is we have this hang point right here from our rings as part of our rescue system. We didn't need this hang point on the actual 4K anchor because we were set back and we had an anchor that was a little bit higher, so we didn't need this hang point. General highline rigging practices were also used on this anchor, so everything is strong enough, independent, and redundant. And what our definition of strong enough for this anchor was, everything needs to be at least 60 kilonewtons. Remember that we're rigging in our backyard, so this doesn't look exactly like it did on the 4K. So these ground anchors are stand-in for our anchor systems that we had, and this was actually a 3-point BFK that this was clipped to. So our MPD is clipped to our 3-point BFK back here, and it goes through our MPD, and then that goes up to our releasable system. We have 2 MPDs so that they're redundant and independent of each other, and we chose MPDs because their braking strength is high enough that we can have them in the system while people are on the highlines. They are also able to be released up to about 5 kilonewtons, at which point they start to get very difficult to release by hand. And we have them on a 5-to-1 pulley system, so theoretically the most they'll ever see is 4 kilonewtons when we need to release if we get to that 20 kilonewton emergency situation. Now that we've seen how the MPDs are connected back to one of our anchors, we'll follow that through the system and talk about how it's connected to the releasable portion. So, like I said before, imagine that these are double SMC pulleys because their rating is high enough to be used in the system, and it's redundant and independent of each other. So we have our pulley systems clipped to our rigging plates. We have 2 rigging plates on either side. And it weaves through, so that makes a 5-to-1 system, which means that if the high line gets to our D-rig tension of 20 kilonewtons, then the tail is actually only seeing 4 kilonewtons. In a real scenario where you would be releasing the system, you want to release both MPDs at the same time so they're actually equalized, which means each MPD is really only going to see about 2.5 kilonewtons. Now that we've talked about the releasable system, we're going to come back to our hang point and talk about all the strengths. So we have 5mm Dyneema, which is rated to about 22 kilonewtons, and we have 6 strands of it, so this hang point is about 120 kilonewtons. We have steel bomber rings, which are going to be significantly stronger than aluminum, and they deform way higher. We have a double wrap soft shackle on either side of the line grip, and that's for strength purposes. And the line scale itself is rated to 90 kilonewtons. The electronics break at 30 kilonewtons, but we don't plan on going that high anyway, so it's all right if we put our electronics at risk. And then that's backed up with a Dyneema sling, and this is rated to about 100 kilonewtons. Now we have 2 rigging plates, and we chose to have 2 of them for strength reasons. The rigging plates are rated to 40 kilonewtons each, so 2 of them makes them redundant and gives us 80 kilonewtons of total strength at this point in the system. And then you'll notice all of the carabiners we use are steel. And then now again we have 2 rigging plates and then our normal Highline anchor. So we've got a steel shackle and a mighty lock with our web lock with a double soft shackle wrap. And then all the way up at the front here we have a normal web lock. Of course we had a 20 mil web lock with 20 mil webbing for the 4K. Normal tie off, double wrap soft shackle for strength, clipped off, and something that was unique that we did was we used, this is 20 millimeter webbing, but we used 20 millimeter into a hard shackle on the bow side with a mighty lock, and we reached out to the manufacturer and there is no significant reduction in strength if we used it on the bow side versus the pin side, just because the hard shackle doesn't actually fit into the rigging plates on the other direction, and that was clipped off. So that's our master point on the home side. On the static side, it was a traditional static without a soft release. So it was just sewn loops clipped into the hang point over there. That's our overview of the 4K Highline.